for calculus 5.5 day 2. In the previous day, we had double angle formulas. Well, we also have half angle formulas, and that's what we're going to be looking at today. And so we have these half angles formulas: sine u over 2, cosine u over 2, and tangent u over 2. And these are power reducing formulas. And we're really not going, I'm not going to spend time right up front talking about that because the application of how to reduce powers with it needs to come later. It's a little bit more complex to kind of grasp right away, but they are used for that. And so kind of interesting in these is that you will see this plus or minus for sine of u over 2 and cosine of u over 2. For tangent, you don't have to worry about it. You don't see a plus or minus. And how you choose whether it's positive or negative depends on the quadrant which u over 2 lies. So you're going to be looking at this angle, figuring out what quadrant it is in, and then you choose according to whether sine is positive or negative in the quadrant u over 2 falls in. You choose positive or negative here. Again, you're going to be looking at where does u over 2 fall? Is cosine in that quadrant positive or negative? And that is how you choose this. So the answers don't come out plus and minus. It is either positive or negative according to the quadrant that u divided by 2 falls. So we'll do some more of that. We'll talk about that as we choose whether it's positive or negative on that right-hand side. But it's pretty important. So you will be given directions using a half angle formula. If you use an addition or subtraction formula, when we say use a half angle formula, you will not get credit. So by using a half angle formula, you've got to use one of these. And so when you see that cosine of 105 degrees, and I say use a half angle formula, you need to be thinking that the 105 degrees is u divided by 2. So the 105 degrees is u over 2, multiply both sides by 2, and we have 210 degrees is u. And that's going to be important as you substitute in, because we're using cosine of a half angle formula, and so cosine of u is here. So that's going to be your 210 degrees. But your u over 2 is 105, and that is that angle right there. And remember how I said we use the quadrant in which u over 2 lies to determine if this is a plus or minus, depending on if cosine is positive or negative there. So on this one, the u over 2 being 105, well, we have to figure out 105 degrees is more than 90, right? So 105 degrees rotates around and is in quadrant 2. So u over 2 is in quadrant 2. And cosine in quadrant 2 is negative because cosine deals with x. So when I use this formula right here, I am going to choose negative because that 105 degrees is in quadrant 2. So I want the exact value of cosine of 105 degrees. This is that half angle. 105 is quadrant 2. Cosine in quadrant 2 is negative. That's why I choose that. But now in the formula, I have a 1 plus cosine of u. What is that relationship? between u over 2 and u? Well, u is twice what is here. So I need this to be 2 times 105. This is that 210 degrees right there, all over 2. Remember, there it is right there. U over 2 is the 105. The 105 is, the cosine of 105 is what I'm trying to evaluate. And the 105 is the half angle. But underneath that radical, you are using twice that angle. And how I know I can use a half angle and get an exact value and not need a calculator is because that 210 degrees is one of those angles on the unit circle that I know sine, cosine, tangent, secant, cosecant, secant of. So now I'm going to evaluate and simplify. So I should know the cosine of 210 degrees, but I need 210 degrees is 30 beyond 180. So it's 180 plus 30 degrees. So this is a 30-degree reference angle. This is that 210 degrees. On the unit circle, this is to the left, root 3 over 2, and down 1/2. So that 210 degrees is a fourth or a third quadrant. 210 degrees is in quadrant 3. Cosine is negative in quadrant 3. So, and for cosine 210, I'm putting a negative root 3 over 2. And make sure that radical, if you have to extend it, that it goes over the whole thing. Please do not have it where it's just looking like this, and that 2 is not looking to be underneath the radical. That 2 has to be under the radical. And so that is going to be all over 2. And now you need to simplify that. So now your algebra is involved. At that point, basically, you've got your trig stuff done. Now, can you finesse it so you can rationalize the denominator and work with the fractions? And you need to show work. If you go from this right to the answer, you're going to be losing points. So I want to work to get the numerator to have the same denominator. So I'm going to write the 1 as 2 over 2. And then really it's minus root 3 over 2. And the denominator being 2, I'm going to leave it like that for right now. And so I'm going to need a little more room here. So on the outside I have a negative, don't forget it. And so now that I have a common denominator, I have a 2 minus root 3. That's my numerator, all over 2. But I'm going to need to multiply by the reciprocal of the denominator. So I have this 2 minus root 3 over 2 times 1/2. Again, extend that radical, make sure it's all over it. And that becomes a negative square root of 2 minus root 3 over 4. You're just multiplying the numerators and multiplying the denominators. And that square root of 4 in the denominator is just 2. So this becomes a negative square root of 2 minus root 3 all over 2. And it's okay that it's weird. We have double radicals in the numerator. That's what happens on these. That is your answer. You've rationalized the denominator. So, right here, you've done your trig. Now it's algebra to simplify and rationalize the denominator. Example 2. So using another half angle formula, so it says using a half angle formula. So you have to use a half angle formula on this. And once again, we are given this sine of x is 5/13 and x is between pi halves and pi, which is a quadrant 2 angle. So I'm going to draw a triangle. We've seen this over and over and over again. X is in quadrant 2, so we're going to draw a triangle. I'm going to make this my reference angle. Sine is opposite over hypotenuse. And then to find this leg, do Pythagorean's theorem. Or no, it's a 12, 5, 13, and this side will be negative 12 because we're in quadrant 2. The x value for the ordered pair would be negative 12. But now we're using a half angle formula, and they want you to evaluate these. So there's this question, if x is in quadrant 2, what quadrant is x halves in? Because you have to choose your sign on the outside here. These signs, when you are doing cosine and sine of the half angle, those signs are chosen according to what quadrant u divided by 2 is. Right now, I know u is a quadrant 2 angle. Well, what quadrant is u over 2 in? Because that's going to determine what I choose out here and whether sine of that in that quadrant is positive or negative. So, well, this is the easiest way to do it. I was given that pi over 2 is less than x is less than pi. I need to know what quadrant is x divided by 2 in. So I'm going to divide each of these by 2. So that in the middle, I have an x divided by 2. And pi halves divided by 2 is a pi fourths. You multiply by 1/2, you get a pi fourths. And then you get an x halves, and you have a pi halves. So x halves is between 45 and 90 degrees. It's probably easier to see this in terms of degrees. Pi halves is 90 degrees. Pi is 180 degrees. So what is half of that in between? 45 degrees and 90 degrees. So x halves will always be an angle in quadrant 1. Which means as I go to evaluate these two, the sine in quadrant 1 is positive, the cosine in quadrant 1 is positive. And so when I go back up here, get rid of some of these markings. Because this angle's quadrant 1, right, between 45 and 90, you're going to be choosing positive here. Because this angle is in quadrant 1, cosine in quadrant 1 is positive, you're going to pick positive here. And for tangent, it doesn't matter because these formulas will get you the correct SIGN overall, whether the value of the tangent is positive or negative. So let's look at this. So now we have our triangle, and we want to find the exact value of sine of x over 2. And since x over 2 is in quadrant 1, the sine of a quadrant 1 angle is positive. We choose positive there. And then it is the sine formula, if we go up here, is 1 minus cosine of not half of u, but u. So it is 1 minus cosine of x all over 2. And that's where we are going to use this triangle because we have the reference angle there of x. And x is in quadrant 2, cosine in quadrant 2 is negative. And cosine is going to be adjacent over hypotenuse. So cosine of x is going to be a negative 12/13. All over 2. Once you get to here, you've done the trick. It's a matter, can you simplify it from there? And so that's going to be a 13 over 13 plus 12/13 all over 2. We have a 25/13 all over 2. And so when you take 25/13 and you divide by 2, you multiply by 1/2, becomes 25 over 26. And that's, oops, I wrote over 25. That is the square root of 25 over the square root of 26, which is 5 over root 26. Again, positive as you're going down because x divided by 2 was a quadrant 1 angle and sine quadrant 1 is positive. And then you rationalize. You've got to show work on that. Detailed work. So there's sine. Then we need the cosine of the half angle. But again, x divided by 2, we already said, is in quadrant 1. And so cosine of a quadrant 1 angle is positive. And the formula for cosine is 1 plus cosine of x over 2. But again, since this is x and this is x, x is a quadrant. We had to rotate around here, and it's quadrant 2. Cosine quadrant 2 is negative. We already found it in the first one. Cosine of x is negative 12/13. So we get plus, and I want to see that you're specifically choosing positive, and it's not by default, you're just forgetting about it. So put a plus out there to end the first couple of steps. So we get 1 plus that negative 12/13 all over 2, which is that 13 over 13 minus 12/13 all over 2. Again, make sure this radical, extend it if your fraction is going down further. So you get a 1/13 divided by 2, and a 1/13 divided by 2 is a 1/13 times 1/2. So you get the square root of 1 over 26, which is 1 over root 26. So rationalize is square root of 26 over 26. And that is your value of your cosine of x over 2. If you get to that value too quickly, you will not get credit because you have to show use. When it says using a half angle, you have to show use of it, and you have to show me specifically how you're simplifying so that I know that you are doing it and not just putting it into some calculator or Desmos and having it do the work for you. I want to see that you know how to do it. Then we have the tangent of x divided by 2, and we have two choices. It can be either one. I'm just going to use this first one, and tangent of the half angle is 1 minus cosine over sine. That's the more traditional one to be using. So tangent of u divided by 2 is 1 minus cosine over sine. That's what I'm going to use. And there's no plus or minus to have to pick. When you correctly use the SIGN, the sign of cosine of u, sine of u, remember, in this case, I used u, but I should go back here and change it to x. Knowing x is in quadrant 2, cosine of x is going to be negative, sine of x will be positive because x is quadrant 2. When you use those correct SIGNs, the correct sign according to the quadrant, this will evaluate to the correct sign for tangent. So we've seen cosine of x over and over. It's a negative 12/13. Sine of x is 5/13. It was given to you. But also if you use that triangle that we set up right here, it's opposite of our hypotenuse, and in quadrant 2, sine is positive. So you could multiply by 13 over 13, that makes it go faster, or you can say 1 is 13 over 13 plus 12/13. That's your numerator, all over your 5/13. And you get 25 over 13 in the numerator divided by 5 over 13 in the denominator. And so those 13s, you can just say those 13s cancel, or you can do 25 over 13 times the reciprocal, and 13s cancel. That way you get 25 over 5, which simplifies to 5. And that is the value of your tangent of x divided by 2. So you might want to look through all that again and hear through it because there's a little bit more going on there. All right, example 3. Solving using half angles. So just as in day 1, you need the angles to be at the same level. Whoops. Again, there are cases where you can have them be at different. What I mean, you need them all to be x's or x divided by 2 or 2x's. You want to work and look for a formula that can get this entire equation all in terms of an x and x halves or a 2x. And since we are in the half angle section of this, and I see this right here, I'm thinking, well, we probably want to use that half angle. And you need to know, make use of structure and realize that this is no different than sine of x halves being squared. That's the same thing. Sine squared of x halves is the same as sine of x halves being squared. And since we are just learning this formula, it probably makes sense to look at that formula. And for sine, it's that 1 minus cosine x over 2. There it is. It's 1 minus cosine x over 2 with a plus or minus on the outside. And since we're using x, we'll use x here. And that's the formula for the half angle. So I am going to substitute this in because this right-hand side is in terms of x, and I'm going to be able to get everything in terms of x that way. So I've got 4, and I have this plus or minus. Make sure that square root goes over all of it. And that quantity is going to be squared equal to 1. And whether it's positive or negative, when I square it, I'm going to get that 1 minus cosine x over 2. They're both going to be positive. So you just square that radical, and it's 1 minus cosine x over 2. And then this 2 can go into that 4 2 times. And now we're starting to get to something that feels a little more comfortable, hopefully. Distribute the 2. And this one, if I subtract 2 on both sides, that leaves me with this. It's not dividing, right? We're just subtracting 2. I'm going to get rid of this. We are just subtracting 2 on both sides, and that leads us right to this. And on this one, you want to factor out the cosine of x. We've seen this. And solve either. So being equal to 0 is important because you're using that zero product principle. Two things multiply to be 0. The only way that can happen is if one is 0 or the other. So either cosine of x is 0 or cosine of x minus 2 is 0. And the second one makes cosine of x is 2. And where is cosine of x 0? Well, it's on that unit circle where your x values are 0. And it is at pi halves and at 3 pi halves. And the amount of term between each of those is pi. So if we had infinite, I could do pi halves plus n pi and an element of the integers, but we are only looking for 0 to 2 pi. So the solutions to this are going to be pi halves and 3 pi halves. And for cosine of x equaling 2, it's not possible. There's no place on the unit circle where the x coordinates are ever going to be 2. The other thing is think about the cosine graph. Cosine graph starts at 1, goes to 0, -1, 0 to 1, and repeats. It never reaches a height of 2. This is not possible. So your solutions from 0 to 2 pi are pi halves and 3 pi halves. And then, as always on these, we get some verifying identities. And we're trying to verify this identity that cosine to the 4th x minus sine to the 4th x is cosine 2x. And you don't necessarily know which way is the best way to go. But right here, I happen to know that's going to factor. If I had a x to the 4th minus y to the 4th, so this kind of goes back to, scaffolding back to problems you've had before. If I had x to the 4th minus y to the 4th, that's x squared plus y squared times x squared minus y squared. That would give you, it's a difference of squares. It's kind of like if it was x squared minus y squared, it would be x plus y, x minus y. But they're to the 4th, so x squared plus y squared, x squared minus y squared. And maybe it'll work, maybe it won't. But then this is, you're extending that to I have a cosine of x to the 4th minus sine of x to the 4th. And so it's going to factor a cosine of x squared plus sine of x squared. It's not how we write it. Cosine of x squared minus sine of x. This is not the traditional way to write it. The whole idea is, it goes back to what is your background on factoring? Can you see that something to the 4th minus something to the 4th is a difference of squares? And so this is going to factor, we write it cosine, that's where the square goes, x plus sine squared x, and cosine squared x minus sine squared x equaling cosine 2x. And this is 1. And so now I have cosine squared x minus sine squared x equaling cosine 2x. And that's an identity. We had cosine of 2u is cosine squared u minus sine squared u. It's one that we developed using the addition formula for cosine. And so that left-hand side is cosine of 2x. So it equals that right-hand side. And you've shown the left side equals the right side using your different identities from chapter 5. That's it.